Hello dear students. So last time we are studying Atwood's machine. ठीक है ना बेटा? Okay. So we are done with the Atwood's machine. Okay. So only just two equations you have to memorize for the Atwood's machine, and that is number one is that acceleration of the Atwood's machine is equal to what's that? What is it equal to? That's equal to twice product m1 m2. Oh sorry. That's equal to larger mass m2 minus m1 multiplied by g divided by m1 plus m2. Okay, difference in the mass is divided by summation of the mass multiplied by acceleration due to gravity. Okay, that's the acceleration of the Atwood's machine. And number second is that tension is simply twice product m1 m2 divided by sum of the masses m1 plus m2 multiplied by g. Okay, you will have to memorize only these two equations in order to do a problem on the Atwood's machine. Okay, so we are done with that, and we have done the previous examples on that as well. Okay, now let's concentrate on this example. अब ध्यान रखो बेटा. Now here we have two blocks. Okay, so this here block A. Suppose this is block A, and this is block B. Okay, this is block B. Okay, now block A is its mass is 4 kg, and mass of the block B that's equal to 6 kilogram. Okay, and they are connected by single string. Implies that when they are connected by a single string, it implies that the acceleration of this block and the acceleration of this block must be same. It has to be same. Okay, so obviously this will go in the downward direction. Suppose with some acceleration A, this will go in the forward direction, in this direction with an acceleration of A. Okay, now the question is like this: calculate the acceleration of the system, or calculate the acceleration of block A or the acceleration of the block B, and that then part B is that calculate the tension string. Suppose the tension here that's equal to T. From here to here there is a single string, so tension here that will be also equal to T. Okay, tension string you have to calculate. And number third part is that you are supposed to calculate the force on the pulley due to the string. Okay, so this pulley will exert the force on the string will exert the force on the pulley, so you have to calculate that. Or the question can be like this: that calculate the force exerted by the pulley on the clamp. This is called as clamp, which holds, okay, which holds the pulley in its own position, at its position. Okay, so that's called a clamp. Or you are supposed to calculate the force exerted by the pulley on the clamp, or the force exerted by the clamp on the pulley, or the force exerted by the pulley on the string. Okay, so all these forces will be equal because they are simply action reaction forces. ठीक है ना बेटा? Okay, so let's try to calculate the value of the acceleration. Okay, so simply in this system, whenever there is a system, it's connected by a single string, so that the acceleration of each block is same. In that very case, we'll generalize it. We'll write it like this: that the acceleration is equal to summation of all the external forces. Simple. This is the generalized this equation for the acceleration: summation of all the external forces divided by summation of all the masses. This is the simplest equation we have. Just memorize this equation. You can do all these examples with the help of only this equation. Okay, so now concentrate on this. Okay, so how many forces are there? So on this, you will construct the free body diagram for this. In the downward direction, there is simply 6g. ठीक है ना बेटा? This 6g is the only force that is responsible for the acceleration of the system. ठीक है ना बेटा? Here we have the forces like there is tension string. In the upward direction there is normal direction. In the downward direction there is weight. They counterbalance each other. This tension form action reaction pair. Again they counterbalance each other. Okay, so there's only one external force which is responsible for its acceleration, and that's simply 6g. ठीक है ना बेटा? So here I will write down it is equal to 6g. There is the summation of all the masses. There are only two masses, so 6 plus 4 or 4 plus 6. So it is equal to the 6 into g, that's 60. That means 6 plus 4 is 10. So the answer will be what? Acceleration is simply equal to 10 meters per second square. Sorry, 6 meters per second square. This and this will cancel. So the answer is 6 meters per second square. This is the acceleration. And acceleration of A is same as that of the acceleration of the B, and both are equal to 6 meters per second square. Okay, ठीक है ना बेटा? So what to memorize is this: that whenever there is a system and such that the acceleration of each particle of the system is exactly same. That in that very case, the generalized equation simply acceleration is equal to summation of all the external forces, that is summation of all the masses. This simply NLM second. This Newton's second law of motion. Newton's second law of motion, which we are applying here. Okay, so external force simply the 6g, and this, and that means within a fraction of a minute you can do this example. Okay, so this is A part. We are done with the A part. ठीक है ना बेटा? Now next is that you are supposed to calculate tension. In order to calculate tension, you will have to construct free body diagram either for 4 kg block, that's for the block A, or for the block B. Okay, but it will be easier if we construct the free body diagram for this block A. Solving the problem will become easier, okay, a bit easier than this block B. Okay, so B part is that you have to calculate the tension string. So do this. What to do is this: so this is block A, its mass is 4 kg, In this direction there is tension string T. In this direction it accelerates along this direction with an acceleration of A, and that's how much? 6 meter per second square. That's 6 meter per second square. ठीक है ना बेटा? Okay, so simply again you will use the Newton's second law of motion, and that's like this: ma is equal to summation of all the external forces. As simple as that. Ma equal to summation of all the external. In addition to this T, there is also that normal direction in the upward direction, there is weight in the downward direction, but those forces are not responsible for acceleration because those forces are perpendicular to the acceleration. So in that direction of acceleration, there is only one force, and that is tension in the string. Okay, so what is the mass of the block? There is 4, so it will be 4 multiplied by acceleration, that's equal to 6, will be equal to summation of all the external force, simply T. So we are done with the problem, so that's 24 Newton. As simple as that. Okay, na beta? So we are done with the tension as well. Okay, so with the part B as well. Now you are supposed to calculate, next is that you are supposed to calculate this force on that string. Okay, force exerted by the string on the pulley. Okay, so that's C part. Ab dhyan rakho beta. For example, this is a pulley. Let's construct the free body diagram for pulley. Okay, so here I will write down FBD, free body diagram for pulley. Free body diagram for pulley. Dhyan rakho beta. Okay, so this is a pulley. I will simply denote it by this dot. Its mass equal to 0 because we assume that the pulleys are massless. Okay, so in this direction there is one force, that is tension string. In this direction there is another force, that is tension string. So in this direction there is T. In this direction there is T. Okay, so they are mutually perpendicular, implies their resultant will be along this direction. And what that resultant will be, that will be force on the pulley FP, and that will be equal to simply root 2T. Okay, na beta? Because they are mutually perpendicular, so it will be root 2 multiplied by T. So simply here I will write down that the force on the pulley is equal to root 2T, and T we know that it's equal to 24. So the answer is simply 24 multiplied by under root 2 Newton. So here's the answer. So this is the force on the pulley. Okay, so first of all you are supposed to calculate, you will have to calculate the acceleration first of all. You cannot calculate tension directly, because if you see this equation clearly, you cannot calculate tension without knowing the acceleration. So we will have to start with the acceleration, and acceleration is simply like this: it's equal to summation of all the external forces, that is summation of all the masses. Okay, so there's only one external force, that's the driving force for the system, and that is the 6g. So here 6g divided by summation of the masses. So we're done with the problem. 6 meter per second square. You can construct free body diagram. This you can construct free body diagram for this as well, but this will involve two forces. One is tension string, another is 6g. You want to minimize the force in order to simplify the problem. So for that, what you do is this: construct free body diagram for this. Simply T, Newton's second law of motion, tension is 24 Newton. Done. Free body diagram for the pulley. Okay, now this is pulley, downwards tension, in this direction tension, they are mutually perpendicular. Resultant will be obviously root 2T. Okay, vectors. This is this equation from the vectors. Force on the pulley is equal to root 2T. Then T is 24 Newton, so answer is 24 under root 2 Newton. Simple. Okay, na beta? You simply pause the screen and write it out. Okay, concentrate on example number 2. So now there are 3 different blocks: block A, B, C. Mass are mentioned. This 2 kg, this 3 kg, this one is 5 kg. Okay. Now same question is that you are supposed to calculate acceleration and tension strings. Now there are 2 strings. One string from this point, this very point. Suppose tension in this string is T1, so here it will be T1. Okay, and this is one more string. Suppose the tension in this string is T2, so you will have to calculate both T1 as well as T2. Okay, so here I will write down T1 and T2. You will have to calculate T1 and T2. And number second is the number C part is that you are supposed to calculate the force on the pulley. Okay, so in this illustration that will be simply root 2 multiplied by T1. Take na beta? Okay. Now concentrate on this. Again, I will write down this. These are 3 different blocks: block A, block B, and block C. Okay. So again, the acceleration of each block will be same. So if this goes downwards with 5 meter per second square, this will go forwards with 5 meter per second. This will also go in the forward direction with the 5 meter per second square. So it means that the acceleration must be same. Okay, when the acceleration is same, so simply this equation equal to summation of all the external forces divided by summation of all the masses. Okay, na beta? And how many driving forces are here which are responsible for acceleration system? Answer is only one, and that's the weight of the block C. Taken up it. So in the downward direction there is weight, and that's equal to 5 multiplied by g, or that is simply 50 Newton. And this 50 Newton is responsible for acceleration. This T1 internal forces don't create acceleration. Here we have normal reaction upwards, weight downwards. They are perpendicular. The acceleration don't create acceleration. Normal reaction, weight of this again perpendicular to acceleration, don't create acceleration. So there's only one force which is responsible for acceleration. So simply that's equal to 50. That is the summation of all the masses, that is 10. 5 plus 3 plus 2, that's equal to 10. तो आंसर सीधे निकला 5 मीटर पर सेकंड स्क्वायर, सिंगल लाइन आंसर. ठीक है ना बेटा? No rocket science. So B part is that you are supposed to calculate tension. Now how many tensions are there? Obviously two tensions, tension T1 and tension T2. Okay, so you can calculate tension T1 and T2 by constructing the free body diagram. So let's first of all construct the free body diagram for this, for 5 kg. So this is a 5 kg block. Okay, how many forces are there on the 5 kg block? So obviously two forces. Upwards focus tension T1. In the downward direction there is what? That is 50 Newton. You can have 5g, that's equal to 50 Newton. It accelerates upwards or downwards, obviously downwards. And what's the acceleration of this? That's equal to 5 meter per second square. 5 meter per second square. Okay, so we'll apply the Newton's second law of motion for this very block, and that's like this: ma equal to summation of all the external forces. Summation of all the external forces acting on this block. Now, if you construct free body diagram for this 5 kg block, or for the block C, the tension T1 now acts as the external force. If you construct the free body diagram for the whole system, T1 will not act as the external force, that is an internal force. Now if you construct the free body diagram only for the 5 kg, this one will act as an external force. Okay, so नीचे की दिशा में, and take those forces positive which are in the direction of acceleration, those forces negative which are opposite to the direction of acceleration. That means this has to be taken as positive and this has to be taken as negative. So ma, that's equal to 5 5 is 25. So here I will write down 25. This I will take positive, so 50 minus negative, so that is T1. Okay, so from there I can calculate T1. T1 यहाँ आ जाएगा. T1 will be equal to 50 minus 25, that's 25 Newton. So we are done with the T1. ठीक है ना बेटा? Okay, now next is that you have to calculate T2. In order to calculate T2, you can construct free body diagram for the 3 kilogram block, because T2 will act on the 3 kilogram block as well. Or you can construct the free body diagram for the 2 kilogram block, or that's for the block A. But better is that you construct the free body diagram for the block A, simply because on block A there's only one force, that's T2. On block B there are two forces, T1 and T2. So obviously this will become simpler. Okay, so here I will write down, this is block A, its mass is 2 kg, and this is block A. It accelerates in this direction with an acceleration of how much? 5 meter per second square. ठीक है ना बेटा? With an acceleration of, that is 5 meter per second square. Okay. Okay, so in this direction there is a force, and that's T2. So again ma equal to summation of all the external forces. Now it will be like this: 2 5s are 10 equal T2. सीधे तो आंसर T2 is equal to 10. बस हो गया. ठीक है ना बेटा? T2 is equal to 10 Newton. Now next is that C part. You will have to calculate the force on the pulley. Again you will have to calculate the force on the pulley. Construct the free body diagram for the pulley. So this is a pulley. There are two forces on the pulley. In this direction there is tension T1. नीचे की दिशा में tension T1. They are mutually perpendicular and they are equal. Resultant will be along this direction. That force on the pulley will be equal to √2 multiplied by T1. So that means the force applied by the spring on this pulley will be in this direction. इस दिशा में होगा. It will be along this direction. This is the force on the pulley. And that's simply this. So the force on the pulley is equal to √2 multiplied by T1. अब T1 कितना निकला? 25. So the answer is simply 25 under √2 Newton. Okay, ठीक है ना बेटा? We start from here. Acceleration is equal to summation of all the external forces divided by summation of all the masses. Done. Construct free body diagram. For this calculate T1. For this calculate T2 by applying Newton's second law of motion. ठीक है ना बेटा? You just practice it. Okay, with every problem you will see that you are doing the problem with no time. Okay, absolutely with no time. So you pause screen and write it down. Okay, another example number 3. Almost similar system. Here are 3 different blocks. Let's suppose that this is block A, this is block B, and this one is block C. Okay, now the question is that calculate the acceleration and calculate T1 T2. There are how many strings? 2 strings. From here to here 1 string, from here to here another string. So how many strings are there? 2 strings. And number next is that calculate the force on the pulleys. How many pulleys are there? 2 pulleys. Suppose this is here pulley 1 and this one is pulley 2. So you will have to calculate the force on the pulley 1 and pulley 2. Suppose tension here that's equal to T1. So यहाँ कितना होगा बेटा? T1. Okay, so in this direction there is T2. So in this direction there will be T2. ठीक है ना बेटा? Okay. So first of all you have to calculate acceleration. Okay, now it's quite obvious from the common sense. Applying your common sense, it's obvious. 5 kg is greater compared to 3 kg. So obviously this will accelerate downwards, so this will accelerate upwards. ठीक है ना बेटा? If suppose you will assume that this accelerates upwards and this accelerates downwards, its answer, you will finally see that its answer will come out to be negative. Suppose that the acceleration of the system is equal to, let's suppose that acceleration is equal to 5 meter per second square. ठीक है ना बेटा? Let's assume that the acceleration is how much? 5 meter per second square. If you will take the direction downwards, so acceleration of this in the upward direction, final answer will be simply a is equal to 5 meter per second square. Now suppose that you will assume that this is going upwards and this is going downwards, final answer will be acceleration a equal to minus 5 meter per second square, which means that the assumed direction and the actual direction are opposite to each other. We'll have to change the direction of the acceleration. ठीक है ना बेटा? Now from common sense, it's quite obvious. From common sense, this will accelerate downwards with an acceleration of a. This will accelerate upwards with an acceleration of a. So this will accelerate forwards with an acceleration of a towards right with an acceleration of a. And acceleration of all the three blocks will be same. It's obvious. The reason is this, that these two blocks are connected by single string, means that suppose acceleration of this is 2 meter per second square, so obviously acceleration of every point of the string will be 2 meter per second square, which in turn means acceleration of block B will be 2 meter per second square. And then the block B and block A are connected by the same string, which means that if acceleration of this is 2 meter per second square, so the acceleration of this has to be 2 meter per second square. Only in such a situation the string will remain tight. Taken a bit throughout the problem, okay, throughout the motion of the system, okay. So we assume an acceleration of this a downwards, acceleration of this is upwards, so acceleration of this will be obviously towards right, okay. Now again, since the acceleration is same, so again same equation, single line answer, summation of all the external forces, there will be summation of all the masses. Taken a bit, okay. Now concentrate on this. Now you see how many forces are there which are assisting acceleration and how many forces are there which are opposing acceleration. Take those forces positive which are in the direction of acceleration and take those forces negative which are opposite. ठीक है ना बेटा? तो इस दिशा में है एक, there is a force and that is weight, and how much is that? 5g, which is equal to 50 Newton. ठीक है ना बेटा? Okay, and on this block there is normal reaction weight, they are perpendicular to acceleration, so don't create acceleration, so they don't create acceleration. ठीक है ना बेटा? Now there is acceleration upwards in this direction, there is force, that is weight 3g, which is equal to 30 Newton. ठीक है ना बेटा? That is how much? That is 30 Newton. Obviously this is in the direction of acceleration, 5g नीचे, acceleration भी नीचे, so in the direction of acceleration. यहाँ acceleration ऊपर और 30 downwards. ठीक है ना बेटा? So summation of all the external force will be simply 50 minus 30, because this is in the direction of A, here 30 is opposite the direction of A, so this has to be taken as negative. Here the summation of all the masses, that's 5 plus 2 is 7, 7 plus 3 is 10, so 10, 50 minus 30 is 20, 20 by 10 is 2 meter per second square. So the answer is simply 2 meter per second square is the acceleration of all the three blocks. Take it, beta. Now next is that you are supposed to calculate tension T1 and T2. In order to calculate T1, construct free body diagram for this. In order to calculate T2, construct free body diagram for this. Take it, beta. So free body diagram for, so B part is that you will have to calculate T1 and T2. So here it is, this is block, its mass is 5, this is block C. ऊपर की दिशा में क्या है बेटा? T1. नीचे की दिशा में क्या है बेटा? That is 50. तो नीचे की दिशा में acceleration कितना है बेटा? That's equal to 2. Okay, so simply you will use the equation, that is ma equal to summation of all the external forces. As simple as that. Okay, so it will be 5 2s are 10. Then take those forces positive which are in the direction of acceleration and those negative which are opposite. So 50 positive minus T1. From here you can calculate T1. तो T1 कितना निकलेगा? T1 यहाँ आ जाएगा, 50 minus 10 is 40. So T1 is 40 Newton. ठीक है ना बेटा? So T1 is 40 Newton. Now let's try to calculate what? T2. In order to calculate T2, you can construct free body diagram for block B as well as for block A. Now it's purely your choice. ठीक है ना बेटा? Suppose that for block B, let's construct for the block B. तो ये क्या है बेटा? Block B. In this direction there is acceleration A, that is 2. इस दिशा में है बेटा tension T1. इस दिशा में है tension T2. And tension T1 we have already calculated that. How much is that? That's equal to 40. ठीक है ना बेटा? This is block B, its mass how much? That's 2 kg. So this is block B, its mass is 2 kg. So again ma equal to summation of all the external forces. Ma is 2 2s are 4. Take this positive 40 minus T2. T2 यहाँ आ जाएगा, तो आंसर निकलेगा 36 न्यूटन. 40 minus 4, that's 36 न्यूटन. ठीक है ना बेटा? Then you will have to calculate the force on the pulley. Suppose this is pulley 1, so F1, C part. F1 will be simply equal to root 2 T1. Root 2 multiplied by T1. So T1 कितना है? 40. So the answer is 40 under root 2 Newton. And F2 will be equal to root 2 multiplied by T2. So T2 कितना निकला बेटा? 36. Force on this is F2. Okay. So in this direction T2, in this direction T2, they are mutually perpendicular. So root 2 times T2. So 36 is under root 2 Newton. So this is the answer. So this is force on pulley 2. Simple. ठीक है ना बेटा? Pause screen, write it down. Okay, one more example, example number 4. So now this time this is an inclined plane, okay, and then there are two blocks, block A and block B. Block A has a mass of 8 kg and block B has a mass of 2 kg. Obviously this block will accelerate. Suppose it accelerates downwards, so the acceleration of A, they are connected by a single string, implies acceleration of this will be upwards A. Okay, now the question is that calculate the acceleration, tension in string and force on this very pulley. So this angle is 30. Obviously this angle is how much? That's equal to 60 degree. So this is tension in the string T, and this is the tension in the string T, which we have to calculate. Or you can represent, you can show it like this as well. Okay, na beta? Okay, so let's calculate first of all acceleration. So again, acceleration, simple equation, simplest of the lot, summation of all the external forces, summation of all the masses. Okay, na beta? Now how many external forces are there? Two external force, two external force. One, a component of weight in this direction. Okay, na beta? Weight of this block in the downward direction. So the weight of this block will be simply 2g, that's equal to 20 Newton. Okay, na beta? And component of this in this direction will be how much? That will be equal to 8g sine 30 degree. Now g is how much? 10. Sine 30 is how much? 1 by 2. So 80 divided by 2, that's equal to 40. So this is equal to 40. So this is equal to 40 Newton. Okay, na beta? Obviously 40 Newton is greater than 20 Newton, means that this block will go downwards and this block will go upwards. So take those forces, positive charge in that direction, acceleration that means 40. So 40, this is minus 20 because it's opposite. ये नीचे की दिशा में acceleration ऊपर. That the summation of all the masses 2, 8 plus 2 is 10, 40 minus 20 is 20, 20 by 10 is 2 meter per second square. So this is the acceleration of the blocks. ठीक है ना बेटा? B part is that you will have to calculate the tension string. In order to calculate tension string, construct free body diagram for one of the two blocks. Let's construct free body diagram for the block B. तो ये है B, इसका मास है 2 kg, ऊपर की दिशा में है टेंशन, नीचे की दिशा में है 20 न्यूटन, इसका weight accelerates upwards with an acceleration of A, ma equal to summation of all the external forces. So it will be equal to ma, that's 2A. Sorry, A is how much we have calculated, that's equal to 2 meter per second square. So this is 2, so 2 2s are 4. Will be equal to summation of all the external, take this positive, this negative, so T minus 20. So T कितना निकलेगा? 24 Newton. ठीक है ना बेटा? And next is that part C is that you will have to calculate tension string. For that we'll construct free body diagram for the pulley. Okay, so this is pulley. In this direction there is tension string. नीचे की दिशा में tension string. This angle is 60 degree. Both these forces are equal and angle is 60 degree. ठीक है ना बेटा? So resultant will be along this direction and the force on the pulley will be equal to root 3 multiplied by T because theta is equal to 60 degree. Okay, so force on the pulley will be simply equal to tension कितना है बेटा? That's 24, so it will be equal to 24 under root 3 Newton. Answer. Problem done. Okay, pause screen, write it down.